Hi guys, 7.3, we'll be studying trig integrals. We're going to be doing this on Monday. It's very similar to the techniques that you used first semester. There's a few, there are actually two formulas that you need to have memorized for this section. I'll get into that in just a moment. Start off with a problem. Sine of x cubed, cosine to the fourth of x dx. As you approach these problems, it's really not a new integration technique, it's just the way that you approach them. You'll need the three Pythagorean identities. The sine squared of x plus the cosine squared of x is equal to 1. 1 plus the cotangent squared of x is equal to the cosecant squared of x. And then secant squared of x is equal to the tangent squared x plus 1. You'll need to know those because they are useful substitutions. All right, let's get rid of those. You also, I would recommend that you focus on odd powers. Now, if you look at this problem here, if I let u be the sine, I get the cosine, one of them, not four of them. And then if I let u be sine, I get, cosine, I get negative sine, not three of them. Now, if I focus on odd powers, like this 3 right here, what I can do is I can split 1 off to serve as my dx. That's going to leave me the sine squared of x times the cosine to the fourth of x. Now, if this portion is my du, that means my u needs to be the cosine. The problem is I've got 2 extra signs. However, if I use the Pythagorean identity, I can replace sines with cosines. So this really becomes 1 minus cosine squared of x times the cosine to the fourth of x times the sine of x dx. I'm now going to take this quantity here and distribute it over this difference, giving me the cosine to the fourth of x times the sine of x dx minus then the integral of the cosine to the sixth of x times the sine of x dx. For both of these integrals, I can let u be the cosine of x. Du then is negative sine of x dx. I don't need the negative. Doing the substitution then gives me the negative integral of u to the fourth du plus the integral of u to the sixth du. And the rest, of course, is history. Substituting the u back in, that's negative 1/5 cosine of x to the fifth plus 1/7 cosine of x to the seventh plus c. Perfect. All right, here's another example. If I take the integral of the sine squared of 2x dx, you'll notice that while I have the sine, I have nothing to serve as du. So we're going to use power-reducing identities from trig. The sine squared of x is equal to 1 minus the cosine of 2x all over 2. And the cosine squared of x is equal to 1 plus the cosine of 2x over 2. Something to point out here that you may or may not remember from trig, that argument right there is a 1. This is always double it. Ditto for the cosine. That's a 1. That's a 2. So for instance, if I'm doing the cosine squared of 5x, I'm going to get 1 plus the cosine of 10x all over 2. The 2 in the denominator remains unchanged. All right, remember you can pause this at any time, go back, rewind it, watch it again, because it's so fascinating. All right, I'm going to take this, and I'm going to use my power reducing formula. That's 1 minus the cosine of 4x. That's all over 4 dx. And then I'm going to split it. 1/2 dx minus the integral of the cosine of 4x all over 2 dx. I think I'll take this 1/2 out to the front, and I'll use u substitution. My answer then is 1/2 x minus 1/8 times the antiderivative of the cosine of u du, giving me a final answer of 1/2 x minus 1/8 times the sine of 4x plus c. I hope you can read that. All right, let's see here. There will be times when you have a choice as to what you're going to let u be. For instance, let's do the secant cubed of x, tangent cubed of x dx. I really have two choices. So I don't have two choices on that one. Whoops. I have two choices on this one. First of all, I could let u be the tangent of x. Du then is the secant squared of x dx. I could also let u be the secant of x. So my du then is secant of x, tangent of x. Now on this second option, it's a little more difficult, because if I split off a secant x, let's make a little more room here. If I split it off, I'm going to get the integral secant x tan x dx. That's going to give me one secant here and two tangents. However, I can take the tangent and replace it using a Pythagorean identity, which will give me secant of x. This is secant squared of x minus 1 times secant x tan x dx. I'm now going to take that entire product and distribute it over that difference, which is going to give me secant cubed of x times secant x tan x dx minus the integral of the secant of x times the secant of x tan x dx. In each case, the power of the secant does not matter. This will end up being u cubed. This will end up just being u. I hope that that's clear. I think that's probably enough of a foundation rather to get you through the homework. When I see you after you get back, I'll help you in any way that I can. Good luck.